Alright, welcome to my video on inverses, specifically inverses of functions. Now, to take a function and find its inverse, all you have to do is switch x and y. So, if a function f of x has the coordinate x comma y, then its inverse function should have the coordinate y comma x. So, for example, if I have a function displayed in this table with the coordinates 1, 2, 2, 7, 4, 16, negative 5, negative 7, and negative 9, comma 50, then my inverse function just flips those coordinates. So f of x becomes x becomes f inverse of x. So this is 2, 7, 16, negative 7, and 50, and 1, 2, 4, negative 5, and negative 9. Now to plot these, I'll just go ahead and use some different colors. I'll use red for my inverse there, and blue for my original function. So 1 comma 2, if I'm counting by 2's here, that'd be 1, 2, 2, 7, 4, 16, 8, 10, 12, 14, 16, negative 5, negative 7, and it doesn't look like I'll be able to plot negative 9 comma 50 on this graph. But those are my coordinates. Notice this is not a linear function. It may be the equation, it may have a proper equation, but right now I'm more worried about looking at the points and how they relate to their inverses. So my first point was 1, 2. That means my inverse point should be 2 comma 1. 2, 7 becomes 7, 2. 16, 4, 8, 12, 14, 16, 8, 10, 12, 14, 16. Negative 7, 5. Negative 7, negative 5. My apologies. And again, 50 comma 9 would be a ways out there. But what you will notice is that these points are all exact reflections across the line y equals x. They all match up very nicely across that line. And in fact, the distance from one side to the other will be the same. This looks to be 2 and about a sixth. 2 and about a sixth. So, there you go. That's how you would graph an inverse or find it from a table. Now, looking at it algebraically, if to find our inverse, we switch our x and y coordinate, it makes sense that to find it algebraically, we would switch our x and y variable. So x equals 2y minus 3. But now we like our equations to be in y equals form. So I will simply solve this equation for y. Add 3 to both sides. You'll get x plus 3 equals 2y. Divide by 2 to get rid of that multiply by 2. You'll get x plus 3 over 2 equals y. And this is a perfectly fine inverse equation. And that's all you have to do. Switch your x and y variables and solve for y. Get y by itself. But what if it looks like f of x equals? Well, in that case, we'll do the same thing, except instead of f of x, we'll use a y. So y equals x plus 2 squared minus 9. Switch my x and y variables. X equals y plus 2 squared minus 9. And now I need to solve for y. So you work from the outermost functions in. So the first thing I'll do is add 9 to both sides. And then I will take my square root. Now, whenever you put a square root into a problem, make sure you add plus or minus. And lastly, let's get rid of that minus 2. Please don't put this minus 2 into your square root. Your square root is fine by itself. We will just write that as plus or minus square root of x plus 9 with a minus 2 at the end. Okay? Notice this minus 2 is not under my square root. And that's how you find the inverse algebraically, or from the equation. Now, one of the coolest things about inverses is that you can check your work simply by taking your inverse and plugging it back in for x in your original equation. So if I plug that in, I get 2 parentheses x plus 3 over 2, the expression for my inverse, and then my minus 3 from my original equation. Well, 2 times something divided by 2 will cancel out. You'll be left with x plus 3 minus 3, which is just x. Now, if you have an equation and what you think is an inverse, when you plug it back in, if it comes out to be x, then you have gotten the right answer. This should happen anytime you plug your inverse back into your original equation. So let's check with our other one here. So I have my parenthesis, now my inverse, square root x plus 9 minus 2 plus 2 squared minus 9. Separate my work there, sorry. So, these red parentheses aren't really doing anything, so I'll ignore them. Negative 2 plus 2 is 0, so I get the plus or minus the square root of x plus 9 squared minus 9. Well, the square root of anything, or when you square something that has been square rooted, your square and your square root cancel out. This plus negative is taken care of by the square. That will all become positive no matter what. So you get x plus 9 minus 9, which again becomes just x. Again, because when we plugged in our inverse into our original function, it's simplified down to be x. We know that this equation and this equation are inverses. I'll rewrite that as f inverse of x now. And that's all there is to finding inverses from an equation, a table, or a graph. So again, to recap, given coordinates or tables, you simply have to flip your x and your y coordinate. So if it's x comma y, it becomes y comma x. This leads to your graph being reflected about the line y equals x. And from equations, or algebraically, you switch your x coordinate, your x variable, and your y variable, and then you simply get y by itself, or solve for y, in other words. And if you want to make sure you check your work, take your inverse function and plug it back into your original equation. If your resulting expression simplifies down to be x, you know that your function and inverse, in other words, your inverse function is correct. You know that you have a function and its inverse. Well, thanks for watching.